All right, we're going to go quickly through the Chapter 4 mega quiz. It kind of covered a lot of material there, except for the graphing aspect. So first, we start off with converting each degree measure into radians, each radian measure into degrees. Remember, our conversion factor is pi over 180, or 180 over pi, so that's what I'm going to use here, 180 degrees over pi, so that my pi's cancel out. That's kind of what we want to do there, but everything else reduces too. You can see the 9 divides into 180 20 times. It's left with 20 up there. So what's left up top? I have a 20 times a 4. That's 20 degrees up there. So really, this is just going to be 80 for the answer, 80 degrees. Okay. Let's go down here to this one. This one I got to convert it into radians. Now, you might recall that 60 degrees is pi over 3. So really, I could look at this as two 60-degree angles here, except negative. So I have 2 pi over 3, so negative 2 times pi over 3. If I replace the 60 with the pi over 3, I get negative 2 pi over 3. Okay, if you wanted to use the other version of saying negative 120 degrees times pi over 180 degrees, you get the same result. 120 divided by 180 reduces to 2/3. This one here, you have to find the measure of each angle. So I'm just looking for the angle in red. But I got this reference angle here that is pi over 4. So what's left over? Well, I've got 3 pi over 4 left over here, but I'm going in the negative direction because I'm going in a clockwise pattern. This one, you can see I'm going in a counterclockwise pattern, so I know it's positive. And I'm going all the way over, but leaving 30 left over for this reference angle. So all the way would be 180, so that would be 150 if I'm stopping short by 30 degrees. All right. This next one here, got to draw an angle with a given measure in standard position. 175 degrees, that's really close to 180. So that means I'm coming all the way over here, almost to 180 degrees. And basically that's all you have to draw for something like that. Make sure you put the arrow on this side of it to indicate that you're going in that direction. All right, and you have to do that too. You can't just draw this ray that comes out here. You got to indicate, because it could be going this side. That'd be a negative angle. So make sure you do that. 7 pi over 18. Graphing this one. Now there's a little trick here, because it turns out pi over 18 is, if you think about pi, that's 180 degrees over 18. That's 10 degrees. Pi over 18 is 10 degrees. So when I say 7 pi over 18, I'm really saying 7 pi over 18s, which is 70 degrees. So sometimes it's easy to make a quick conversion there. 70 degrees is about right here. So that's our 7 pi over 18. The reference angle is always the angle that is made with the y, or with the x-axis, positive or negative. So when I'm talking about the reference angle here, this is the angle I'm talking about. So if this is 7 pi over 6 over here, it means I went a pi over 6 past that x-axis, the negative x-axis, so that's the reference angle, just pi over 6. And they're always positive. Reference angles are never negative, and they are never greater than 90 degrees or pi over 2, so be careful about that. All right, 280 degrees, well, this one I made you graph out. So if you think of where 280 degrees is at, graphing this on the xy plane, well, 270 would be all the way over here. So I'm saying go a little bit past it. Go 10 degrees past this angle of 270 degrees here. Well, how much is left to get to the x-axis on this side? Well, I need 80 more degrees to get there. So that's the reference angle. Again, always positive, always going to be less than 90. Closest x-axis is where we're going for. All right, then we got into some of these exact value inverse trigonometric ratios, and this is one where it is really helpful to draw a little unit circle sketch. Cosine always deals with the x value, so where's an x value of -1? That's over here at -1, 0. What's that angle? So it's always talking about these inverse trig ratios. What's the angle associated with them? So that angle is obviously just pi, or 180 degrees would have been acceptable. I didn't say whether you had to do it in radians or degrees. Technically, you could also say negative pi or negative 180 if you wanted. So you could have had any one of those and I would have accepted it. Sine -1/2, so we're dealing with the y value of -1/2. So let's draw our little sketch here again. y, negative 1/2, it's down here. So if I'm looking for an angle that hits that, it would be this angle here, or it could be this angle over here. So acceptable angles would have been saying go all the way over here, that's 7 pi over 6, or this little angle here, which would have been a negative pi over 6. If I went all the way around to this angle, that is 11 pi over 6. If I decided to take a negative route over to here, that's a negative 5 pi over 6. So any of those would have been acceptable, or the degree equivalent of those. All right, and then we had tangent equal to a negative 1. Remember, this is equal to y over x. So that means it has to be something divided by itself. And the only time that happens is at pi over 4 or 45-degree angles on our unit circle. So I'm looking at these angles here, here, or here, but it has to be a negative, so that means either the y has to be negative or the x has to be negative, but not both. So the only time that happens is going to be in quadrant 2 or quadrant 4. So what are those angles there? Let's get rid of these ones here and here. We're not going to have those. It's going to be one of these two angles. This one here is going to be what? It's if you think about counting up pi over 4s, we got 1 pi over 4, 2 pi over 4, 3 pi over 4. So that could have been one possible angle. Or a negative pi over 4, or any one of the equivalents of those, like a negative 45 degrees, or this would have been right here, this would have been 135 degrees, for example. So any one of those would have been okay to use. Okay, let's take a look here at this one. So this wasn't really a trick question. It's just one you need to know that if you are basically doing an operation, then the inverse operation that immediately after that, where we're taking sine of the inverse sine of this, it's just equal to whatever we had here, 5 square root of 34 over 34. That was your answer. You didn't have to really do any work with that one. You just need to know. It's like saying, hey, I'm going to take 5. Let's multiply it by 2. That equals 10. All right, now let's take that 10 and divide it by 2. It equals 5. We end up back where you started. Same idea. All right, the rest of these here, this one was similar, one of those compound inverse trig ratios. Just always start with the inner one first, okay? So sine of pi over 3, let's draw our unit circle on here. Didn't come out right there. So our unit circle, that's a little better. Pi over 3 is a 60-degree angle. That's this one right here, pi over 3. And that point here is going to be 1/2 and square root of 3 over 2. Sine deals with the y value, so we're going to use the square root of 3 over 2. So this is cosine, this thing here is equal to the cosine inverse of square root of 3 over 2. But now cosine deals with the x value. So I'm going to figure out, okay, x values of square root of 3 over 2, that would be over here. This angle here, that long side here is square root of 3 over 2. Now the y value is 1/2. All right, so square root of 3 over 2 for x, 1/2 for y. So that angle there, as you can see, would be either equal to 30 degrees, or since this started off in radians, we should probably give the answer in radians, and that's just pi over 6. All right, so work from the inside out on these. This one, start at the inverse sine of pi, or square root of 2 over 2 rather. But I think everybody knows what that is. Square root of 2 over 2, 45-degree angles. That's, if we go ahead and just draw this on here, that's right up here, square root of 2 over 2, comma, square root of 2 over 2. So that angle is indeed 45 degrees, or pi over 4. So really, we're going to change this into the tangent of, this turns into 45 degrees. Okay, but tangent of 45 degrees is pretty easy. Remember, that's y over x is what we're looking for. But our y and our x are exactly the same. So that just equals 1. Square root of 2 over 2 divided by square root of 2 over 2 is 1. The rest of these dealt with some law of sines, law of cosines situations. So I'll start with this one. I kind of worked it out already. This one here, let me shrink this down so we'll come back to this in a second here. Let me do this little trick if I can. There we go. So we're setting this one up here. We start off with, we want to find AC, which is just side B here. So we'll zoom in on this here. AC here is B. So we want to find what B is equal to. But we're given angle B, we're given angle A, which means we could find angle C by just subtracting those from 180. So angle C then is actually a given. Side C, that's this one right here, is a given. Like I said, we have angle A and angle B. We need to find side B. So whenever you're given only one side, but you're given multiple angles, or all the angles in this case, it's always a situation where you're going to use law of sines. And this is one of the ones you need to have memorized. But the side we're trying to find here is B, so whenever I set up my law of sines, let's see if I can expand this back out again now. Maybe. There we go. Whenever I set up my law of sines, I start by putting the thing I'm trying to find in the upper left corner. Okay, so that means sine of B goes underneath it, but we know what B is. And then sine, or then in C on top, we have that value there, and sine of C on the bottom, that's also a value we know. So we have everything we need here to solve this. So basically I just plug those in. You can see that I do that here. Plug those values in. We still have B in the upper left corner. So all I do is just take this sine of 31, multiply both sides by it, and at that point it's just plugging stuff into your calculator. Just make sure that you are in degrees mode when you get to this point, okay? So your answer in this one was 15, or 15.0, rounded in the nearest tenth. This one down here, this is a situation where we're trying to find angle C. All right, trying to find angle C. We're given side A, or angle A, and then two sides. So we're only given one angle in this case. So that means we can't use law of sines. This is going to be a law of cosine situation. So notice the values that we're given here. We're given an A, we're given a C, we're given an angle, or we're given a angle A, trying to find angle C. Actually, this is a, sorry, I forgot, we're given two sides here, one angle, we're trying to find an angle. So actually we can use law of sines on this one, because it's the angle we're trying to find, not the side length. So in this case, we set it up a little bit different way. Show you the work I have here on this one. I can expand this out. There we go. Almost. Almost. I can do this. It better work. Because if it doesn't, we're in trouble. All right. Oh, I see what it's trying to do to me. Let's try this again here. There we go. All right. Thanks for bearing with me. This one here, you can see there was the sine of C up here we're trying to find. Well, technically we're trying to find C, but we got to use sine of C. So I put the sine of C in the upper left corner. This is C underneath it. Then I have the sine of A up here. That's A, and then little a on the bottom, and the rest of it is just solving for our sine of C. So at one point here, we have sine of C equals all this right here. But if you want to find what C is, you got to take the inverse sine of everything so that you get an angle out of it. So keep in mind your answer on this one is going to be an angle when it's all said and done. All right, so you get 21 degrees on that guy. Let's take a look at this one here. So this is a situation where we are definitely going to be finding things using law of cosines, because we're given one angle, we're given a side, and we're trying to find another side. So that last situation where we're trying to find another angle and we're given one angle and two sides, we could use law of sines. But this time, law of cosines really is our only thing we can use on this. So work-wise, looks like this. If I can get this one to work properly, there we go. Work-wise, we end up with this here, and you can see I'm trying to find A, so that goes here, but I've got B, I've got C, I've got this B and C, and I have this angle A. So I got everything I need to plug in here to solve for A, or at least find A squared first. So all you do, plug those values in, punch it in your calculator carefully. You get A squared equals 150 point blah, blah, blah. Take the square root of both sides. You get A is equal to 12.3. But part of this is, I'm going to give you law of sines, I'll give you law of cosines. Law of sines, you're going to have to remember that on your own. But sometimes you just got to look at the law itself, like this one, and see what you know and what you don't know. Do a little check mark action like I did here. And finally down here, we're finding some area problems. This one here, anytime you are given all three side lengths, we're going to use Heron's formula, okay? So Heron's formula says if you find S, which is 1/2 A plus B plus C, or we've got P, R, and Q here, but it doesn't really matter. Just if you have three side lengths, you can plug them then into this formula, S times S minus A, S minus B, S minus C. And it's really a pretty simple formula. You just got to be careful when you plug everything in. So I found the S here, and it is 17.4. And when you plug it in over here, carefully, again, like I said, it's kind of the biggest thing on this is carefully plugging in. You end up with 52.8. Now make sure you are writing units on your answer. This one was given in centimeters. Its area, which is centimeters squared. Okay, so you might lose points if you're not careful about that. And finally, this one, we're given side A, side C, and angle B. It's an SAS situation, which ends up being that we have formulas for this, for area of a triangle if we're given a side angle side situation. And this is our formula, 1/2 AC sine of B. Basically just plug those numbers in if that's your situation. So part of it is just recognizing that that's your situation. So what's the work look like? 1/2, 5.6 times 10 sine of 29. You end up with 13.6 meters squared. Don't forget the meter squared on that. And I think that's our last one here. Yep, so that was all the stuff from the mega quiz, which some of that you will be given the law of cosines, you'll be given Heron's formula, and the area of triangle given SAS. But you still need to know your unit circle, your law of sines, and you need to know your inverse trig stuff with your unit circle.